Okay, here's the answers to the multiple choice of the Christmas paper that I handed out. It was due today. So question 1, these are all for 1 mark. 1 mark each for these 13 multiple choice questions. Mark yourself out of 13. So the first question, the symbol for this is what one of these 5, and the answer should have been an LED. An LDR, a light dependent resistor, is that. A transistor, remember, we've done quite a bit of work on transistors. A transistor looks like that. A photovoltaic cell, we didn't do much on, but a photovoltaic cell looks like that, a positive and negative side. And a thermistor, looks like that. So the answer is C. If you got C, give yourself 1 mark. Right, number 2. A uniform electric field exists between Q and R. That must mean that Q and R must have, one must have a positive side, one must have a negative side. And we're putting a particle P through this electric field and it's been attracted to side Q. So if it's been attracted, then P and Q must have opposite charges. Remember, opposites attract, like charges repel. So if you have a positive and a negative charge, they're going to be attracted to each other. If you have 2 positive charges or 2 negative charges, they're going to be repelled. So P and Q must have opposite charges. So we can rule out B straight away because both are negative. We can also rule out E because both are positive, which is not going to happen. C and D both have no charge on particle. If there was no charge on the particle, then it would go straight through. It wouldn't get attracted, so it cannot be C or D. And the answer is A, because the charge on this particle is negative, the charge on plate Q is positive, charge on QR is negative. So when particles being going through here, it's being deflected by R and being attracted up to Q because they have a negative charge. So the answer is A, 1 mark. Number 3. So it's saying that the reading on ammeter A1 is 5 amps in here. So we must know that must be the total current in the system. So it'd be 5 amps over here, and then it also must be 5 amps in the middle there, in here. So it's saying A2 is 2 amps and A4 is 1 amp. So when 5 amps gets to here, because this is a parallel circuit, it needs to split up. So it's telling you that 1 amp is going up here. So if there's 1 amp there, it must be 4 amps down here. Those rejoin to make 5 amps in the middle, and then here again it must split up. But there's 2 amps to the top resistor there, so it must be 3 amps. So the answer is 3 amps and 4 amps, 3 amps and 4 amps. So the answer for number 3 is D. 1 mark if you got that. 2 resistors, number 4. So we have to calculate the total resistance. These are in parallel. It's a parallel circuit. And to calculate total resistance in parallel, you do 1 over RT equals 1 over R1 plus 1 over R2. So that's 1 over 8 plus 1 over 24, which would give you 1 over 6. But remember, 1 over RT equals 1 over 6. So the answer is not A. 1 over 6 is 0.16667. Once you get to this stage, you've got to swap over both sides like that. So it's RT over 1 equals 6 over 1. So RT equals 6 ohms. Therefore, the answer is C. 1 mark if you got that. Alright, it's quite a bit of work in number 5. Have a read of that just now. So there's a block as the dimensions shown. It's placed on a table so that one of its surfaces is smooth on a tabletop. The weight of the block is 4.9 newtons. The minimum, and that's been put in bold for you, the minimum pressure exerted by the block on the table is what, one of these three. So you should be able to see from this block it has 3 different sides. So it has a side 0.2 and 0.1 high. So we can calculate the area of that. It also has a side which is 0.05 long, this one here, and 0.1 high. So we can calculate the area of that by times those two numbers. The third area would be 0.2 by 0.05. So you need to calculate the area of those 3 sides and see which one you're going to be using. So the area of this top one is 0.05 times 0.2, which is 0.01 meters squared. This other one is 0.1 times 0.2, so that's 0.02 meters squared. And then this final one, 0.05 times 0.1, which is 0.005 meters squared. So you're calculating pressure, you've got the weight, which is a force, so you'd be using pressure equals force divided by area, 4.9 divided by 0.01, 0.02 or 0.005, and they would have gave you 3 different numbers. It would have gave you 245, 490 and 980. So it gave you B, C and D, but the answer, it was asking you the minimum pressure. So if you were to put it on this side, you should have got the number 245, which was the lower, which is the minimum pressure you could have got. So that's the answer, the minimum, the lowest. 245, so the answer should have been B, 1 mark. Right, number 6, a syringe. You've got 2 volumes in here. You've got a starting volume and a starting pressure, 150 and 120. And you've got the final volume, which is 100. So the relationship between pressure and volume is P1 V1 equals P2 V2. Pressure 1 is 120. Volume 1 is 150. Pressure 2 is the thing you're trying to find out, and volume 2 is 100. So 120 times 150 is 18,000 equals P2 times 100. So when you move that 100 over there, it's timesing on this side, so it's dividing on the other. So P2 equals 18,000 divided by 100, which equals 180 kilopascals. So your answer is C, 1 mark if you got that. Right, number 7, pressure against temperature. Remember pressure, P1 over T1 equals P2 over T2. So as you increase temperature, pressure also has to increase. So you would think that the graph should look like that, but that's only when temperature is in Kelvin, remember. So they tried to trick you here by putting that E in, and E is wrong because it's temperature in degrees C. So you should know it's not that one. It's definitely not C or D because they go the opposite way. So the answer has to be A or B. And you'll notice that one is in Kelvin. If it's in Kelvin, then it should have went straight up like that. So you can rule out B, but when it's in temperature, as in degrees C, because of the minus 273 change from temperature Celsius into Kelvin, this is what the graph looks like when it's pressure against temperature in degrees C. Pressure against temperature in Kelvin goes straight through the middle like that. Okay, so the answer was A, 1 mark. Number 8, you had to find out which one of these was true. Waves do transfer energy, definitely, so that one's definitely right. A wave with a short wavelength diffracts more. We know that's wrong because all long wavelength, like radio waves, diffract more. And the amplitude of the wave, so amplitude is height. The amplitude of a wave depends on its wavelength. No, the amplitude is the height. The wavelength is obviously going this way, and they do not depend on each other. So it was only part 1, therefore number 8 was A. 1 mark again. Right, you need to pick out where the wavelength of this is. Remember, wavelength can be from peak to peak. It can be from trough to trough, or it can be from the start of a wave to the start of the next wave. So it goes positive and negative, or it can be from the end of a wave to the end. So you've got a complete wave there, negative and positive. So it's between S and T. So the answer is E. 1 mark again. Right, question 10. So a stone is thrown into a pool right in the middle here. And then you've got the crests of waves going outward over a period of 3 seconds. So the frequency is how many waves in 1 second. So here you have one wave to here, you have another wave to here, and then another wave to here. So you've got 3 waves in there over 3 seconds. So if you've had 3 waves over 3 seconds, then you've had 1 wave over 1 second. So the frequency is 1 wave per second. So the frequency is 1. So we've narrowed it down to B or C. And the final part is the speed. Speed is distance divided by time, or speed equals frequency times wavelength. You have the frequency, which is 1, and the wavelength, it already tells you here, the distance in there is 1 meter. So it's 1 times 1, 1 meter per second. So it should have been 1 and 1 you were looking for. So the answer is C. 1 mark. Right, number 11. Remember, it's travelling from air. If it travels from air to glass, then it bends toward the normal. So you should have been drawing all your normals on here. B bends away from the normal, so it can't be B. C, A does bend, so does C, so does D. E bends away from the normal, so it can't be that. And remember, when it goes from glass back into air, it has to bend back towards the normal, which A does. C does not, and D does. And when it re-enters glass again, it has to bend towards the normal, which A does, and D does not. So the answer is A. Right, 12, 13, 14, 15 we've not covered yet, so you should just skip straight to 16. So you've been given a speed. You've got a speed 10 meters a second. You've got a mass 80 kilograms. And you've got a time 5 seconds to come to rest. So you have to calculate energy, but it's energy by heat. So before the cyclists move off, she has potential energy. When she starts to move, she has moving energy, which we call kinetic energy. And when the cyclist comes to a halt, that kinetic energy, the potential energy, must be changed to kinetic energy, and that all that kinetic energy must be changed to some sort of other energy. And we're going to assume that it's all being changed into heat energy in the brakes. So all our energies must be the same number. We can't calculate potential energy because we don't know the height. EP equals mgh. We can calculate kinetic energy though, because we have a half mv squared. So it's a half times mass, which is 80, times the speed, which is 10 squared. 100 times 80, 8,000 times a half, which is 4,000 joules. So the answer is D. Right, final question, and then mark yourself out of 13. The minimum amount of energy required to change water. So you've got water, which is a liquid, into its boiling point, steam, which is a gas. So when you change something from a gas to a liquid, that's vaporization. You want to calculate the amount of energy. Energy equals mass times the latent heat of vaporization at 0.5, and then you should have went to your data sheet and got the vaporization of water, which was 22.6. Just let me check this number. 22.6 times 10 to the 5 times by half a kilogram, which gave you the number 1.13 times 10 to the 6 joules, which was D. 1 mark for that. So now mark yourself out of 13, and then please post on the team and let me know what you got out of 13. Right, that completes the multiple choice for the Christmas past paper. I'll go over the long answer questions in due course.